Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method. So I am going to show you the three ways of solving the equation using variation of parameters method in three different parts. So let's begin with part 1. Problem: solve y double dash minus 2y dash plus y equal to x e power x log x for x greater than 0, or d square minus 2d plus 1 of y equal to x e power x log x using the variation of parameters method. We are given a differential equation of order 2. Given differential equation, y double dash minus 2y dash plus y equal to x e power x log x. Consider as equation number 1. We can write y double dash as d square y by dx square minus 2 into dy by dx plus y equal to x e power x log x. We can write d square y by dx square as capital D square y minus 2 into capital dy plus y equal to x e power x log x. Now take y common from all the three terms of LHS. We'll get d square minus 2d plus 1 into y equal to x e power x log x. Equation 1 in operator form is our equation 2. Say f of d into y equal to some function of x, where f of d is d square minus 2d plus 1 and r of x is the RHS part. F of d is d square minus 2d plus 1. Let's now write the homogeneous equation of equation 2. The homogeneous equation of 2 is d square minus 2d plus 1 into y equal to 0. Consider as equation number 3. Now we'll find the solution to this homogeneous equation using the auxiliary equation. Later, using the solution of homogeneous equation, we'll find the general solution of equation 1 and 2. Now coming to the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square minus 2d plus 1, right? Let's replace the differential operator by m, so that we'll get f of m equal to m square minus 2m plus 1. Then the auxiliary equation becomes m square minus 2m plus 1 equal to 0. Now we need to find roots to this equation. This equation looks like m square into 2 into m into 1 plus 1 square equals to 0, which is an expansion of a minus b whole square, right? Expansion of, say, m minus 1 whole square. We can write m minus 1 whole square as m minus 1 into m minus 1. Now equate each factor to 0. Equate each factor to 0. If m minus 1 equals to 0, then m equal to 1. Since m minus 1 is repeating twice, so we'll get m equal to 1, 1. The roots are real and equal. We know that when two roots m1 and m2 are real and equal, then the solution to our homogeneous equation looks like y equal to c3 plus c4x into e power that equal root into x. Here we are taking c3 and c4 instead of c1 and c2 because I want c1 and c2 to appear in the last general solution to our problem, right? Now coming to the solution of homogeneous equation. The solution to homogeneous equation, equation 3, is y equal to c3 plus c4x into e power, we have equal root 1, right? m1 equal to m2 equal to 1. 1 into x, which gives us y equal to c3 plus c4x into e power x, or we can write this as y equal to c3 e power x plus c4x e power x. Right? Therefore, y equal to c3 plus c4x into e power x, or y equal to c3 e power x plus c4x e power x is a solution to our homogeneous equation, equation 3. Let y equal to, now replace c3, c4 constants or parameters with functions of x, a and b. Then we'll get y equal to a e power x plus b x e power x. B, the general solution of equation 1 and 2. We are saying that y equal to a e power x plus bx e power x is a general solution to 1, which is nothing but it is a solution to 1. So it satisfies the equation 1, right? So we need to find y dash and y double dash and substitute in equation 1. Okay. We are having here a and b are functions of x. Now we'll find we'll find y dash and y double dash. We have y equal to a e power x plus bx e power x, right? Let's find y dash. Y dash equals to a e power x whole dash plus bx e power x whole dash, right? Or we can write this as, here we are going to apply the formula uv whole dash equal to u dash v plus v dash u, right? Let's apply this for the first term. We'll get a dash e power x plus a into e power x whole dash plus b dash, consider b as one term, x e power x as another term for our convenience, plus b into x e power x whole dash, right? This gives us a dash e power x plus a into derivative of e power x with respect to x is e power x plus b dash into x e power x plus b into, now let's find x e power x derivative using uv whole dash formula. We'll get x dash e power x plus x into e power x dash, which gives us a dash e power x plus a e power x plus b dash x e power x plus b times x dash, derivative of x with respect to x is 1 into e power x plus x into derivative of e power x with respect to x is e power x, which gives us a dash e power x plus a e power x plus b dash x e power x plus b times 1 into e power x is e power x plus x e power x. Now y dash becomes a dash e power x plus a e power x plus b dash x e power x plus b e power x plus bx e power x. This gives us a dash e power x plus a e power x plus b dash x e power x plus b e power x plus bx e power x. Now write the terms involving a dash and b dash. Firstly, we'll get a dash e power x plus b dash x e power x. Now write the terms involving a and b. We'll get a e power x plus b e power x plus bx e power x. Now let a dash e power x plus b dash x e power x equals to 0. Consider as equation number 4, so that while finding y double dash, a double dash and b double dash will not appear. Now y dash reduces to 0 plus a power x plus b e power x plus bx e power x, which gives us y dash equals to a power x plus b power x plus bx e power x. So we got y dash here. Now we are having y dash, right? Y dash equals to a e power x plus b e power x plus bx e power x. Now let's find y double dash. Y double dash equals to a e power x whole dash plus b e power x whole dash plus bx e power x whole dash. Derivative of first term, derivative of second term plus derivative of third term. Here also we are going to apply u v whole dash formula, which is u dash v plus v dash u. Now this gives us a dash e power x plus a into e power x dash plus b dash e power x plus b into e power x dash plus b dash into x e power x plus b into x e power x dash. See, I am taking x e power x as one single term and b as one term, or b as one function and x e power x as one function for my convenience. Okay, this is equals to a dash e power x plus a into derivative of e power x with respect to x is e power x plus b dash e power x plus b into derivative of e power x with respect to x is e power x plus b dash x e power x plus b into derivative of u v whole dash is u dash v plus u into v dash. This gives us a dash e power x plus a e power x plus b dash e power x plus b e power x plus b dash x e power x plus b times derivative of x with respect to x is 1 into e power x plus x into derivative of e power x is e power x. It gives us a dash e power x plus a e power x plus b dash e power x plus b e power x plus b dash x e power x plus b times 1 into e power x is e power x plus x e power x. Right? Y double dash becomes a dash e power x plus a e power x plus b dash e power x plus b e power x plus b dash x e power x plus b into e power x plus bx e power x. Now write the terms involving a dash and b dash firstly. We'll get a dash e power x plus b dash e power x. Now write the terms involving a plus a e power x. Now write the terms involving b. b e power x and b e power x is 2b e power x plus bx e power x. See, we left one more term involving b dash, right? So let's write it here. Plus b dash x e power x plus a e power x plus 2b e power x plus bx e power x. Therefore, y double dash equals to a dash e power x plus b dash e power x plus b dash x e power x plus a e power x plus 2b e power x. b e power x plus b e power x is 2b e power x. So we got this plus bx e power x. Y double dash is a dash e power x plus b dash e power x plus b dash x e power x plus a e power x plus 2b e power x plus bx e power x. Right? Now we are having y dash and y double dash. Let's put it in equation 1. We have equation 1, y double dash minus 2y dash plus y equal to x e power x log x. Now substitute y dash and y double dash in the above equation. We get y double dash is a dash e power x plus b dash e power x plus b dash x e power x plus a e power x plus 2b e power x plus bx e power x minus 2 times y dash a e power x plus b e power x plus bx e power x plus y a e power x plus bx e power x equals to x e power x log x. This gives us a dash e power x plus b dash e power x plus b dash x e power x plus a e power x plus 2b e power x plus bx e power x minus 2a e power x minus into plus minus 2b e power x minus into plus minus 2b x e power x plus a e power x plus bx e power x equals to x e power x log x, right? First three terms remains as it is. Now write the like terms. A e power x plus a e power x again. Okay, here 2b e power x and minus 2b e power x gets cancelled, right? Okay, minus a e power x minus 2a e power x bx e power x bx e power x and we have minus 2bx e power x, right? Minus 2bx e power x equal to x e power x log x. This gives us a dash e power x plus b dash e power x plus b dash x e power x plus a e power x. A e power x is 2a e power x minus 2a e power x bx e power x plus bx e power x is 2bx e power x minus 2bx e power x equal to x e power x log x, right? So here plus 2a e power x minus 2a e power x gets cancelled and plus 2bx e power x and minus 2bx e power x gets cancelled and this results to a dash e power x plus b dash e power x plus b dash e power x e power x equal to x e power x log x. Consider as equation number 5. Now solve equation 4 and 5 to find a dash and b dash. We are having equation 4 and 5, right? Let's solve these two. Solving 4 and 5. Plus a dash e power x and minus a dash e power x gets cancelled. Plus b dash x e power x and minus b dash x e power x gets cancelled. We'll get minus b dash e power x equals to minus x e power x log x, right? Which gives us b dash e power x equals to x e power x log x. Now let's take e power x to RHS and we'll get b dash equals to x e power x log x by e power x, where e power x gets cancelled, and we'll get b dash equals to x log x. Therefore b dash equals to x log x. Now let's substitute b dash in equation 4 so that you'll get a dash. We have equation 4, a dash e power x plus b dash x e power x equals to 0. We can write this as a dash e power x equals to minus b dash x e power x. Since b dash equals to x log x, let's substitute b dash here. We'll get minus x log x into x e power x, which is equals to minus x into x square e power x log x. Now take e power x to RHS, we'll get a dash equals to minus x square e power x log x by e power x, where e power x gets cancelled, this equals to minus x square log x. Therefore, a dash equals to minus x square log x. We got a dash and b dash. Let's now find a, b. We have a dash equals to minus x square log x, right? A dash is nothing but derivative of a with respect to x. Now let's separate the variables by taking differential dx to RHS, and we'll get dA equal to minus x square log x dx, right? Here the variables are separable, so we can perform integration. Integral dA equal to minus integral x square log x dx. Let's now evaluate integral x square log x dx separately for our convenience. Here we are going to apply integration by parts formula. Integral u dv equal to uv minus integral v du. Here the integrand is a product of polynomial function and logarithmic function, right? Let's take logarithmic function as u and x square e power x as dv. Okay, we have u equal to log x, dv equal to x square dx. Now differentiate on both sides with respect to x. Derivative of u with respect to x is derivative of log x with respect to x is 1 by x. From this we'll get du equal to 1 by x dx. Here integrate on both sides. We'll get v equal to integral x square dx is x cubed by 3, right? Now substitute in this formula. We'll get integral u dv. U is log x into dv x square dx, which is integral x square log x dx equal to u into v. U is log x into v x cubed by 3 minus integral v x cubed by 3 into du 1 by x dx, which gives us x cubed log x by 3 minus here 1x gets cancelled, so you'll get x square by 3, right? You can just write this as x cubed log x by 3 minus 1 by 3 integral x square dx, which is equals to x cubed log x by 3 minus 1 by 3 into derivative of x square with respect to x is x cubed by 3. This gives us x cubed log x by 3 minus x cubed by 9. Therefore, integral x square log x dx is x cubed log x by 3 minus x cubed by 9. Now coming to integration, integral dA is a equal to minus integral x square d log x dx is x cube log x by 3 minus x cube by 9 plus integral constant say c1, which is equals to minus x cube log x by 3 minus into minus plus x cube by 9 plus c1. Therefore, a equal to minus x cube log x by 3 plus x cube by 9 plus c1. We got a. Now we need to find b using b dash. we have b dash equals to x log x. B dash is nothing but derivative of b with respect to x. Again, separate the variables by taking the differential dx to RHS. We'll get dv equal to x log x dx. Here the variables are separable, so you can perform integration. Integral dv equal to integral x log x dx. Let's now evaluate integral x log x dx using integration by parts formula. We have integration by parts formula. Integral u dv equal to uv minus integral v du. Here the integrand is of the form polynomial, product of polynomial function into logarithmic function. We'll consider the logarithmic function as u and the remaining part x dx as dv, right? We have u equal to log x and dv equal to x dx. Now differentiate on both sides with respect to x. We'll get du by dx equals to derivative of log x with respect to x is 1 by x. From this we'll get du equal to 1 by x dx. Here we are going to integrate, so that we'll get v equal to integral x dx is x square by 2, right? Now applying this formula, substitute uv, du and dv. We'll get integral u is log x into dv x dx equal to uv u into v x square by 2 minus v integral v into du is 1 by x dx, which gives us integral x log x dx equal to x square log x by 2 minus 1 by 2 into, if 1x gets cancelled, you'll get integral x dx, right? Which gives us x square log x by 2 minus 1 by 2 into integral x dx is x square by 2, right? This gives us integral x log x dx equal to x square log x by 2 minus x square by 2 2s are 4, right? Since integral x log x dx equals to x square log x by 2 minus x square by 4. Now coming to the integration. Integral dv is b equal to integral x log x dx is x square log x by 2 minus x square by 4. Therefore, b equal to x square log x by 2 minus x square by 4. Right? Plus integral constant. I forgot to write integral constant plus c2. We got a and b. Let's now find the general solution. Therefore, the general solution is given by y equal to a power x plus bx e power x. This is equals to a minus x cube log x by 3 plus x cube by 9 plus c1 into e power x plus b x square log x by 2 minus x square by 4 plus c2 into x e power x. This gives us minus x cube e power x log x by 3 plus x cube e power x by 9 plus c1 e power x plus x square into x cube e power x log x by 2 plus into minus minus, x square into x cube e power x by 4 plus c2 x e power x. This gives us y equal to, write the terms involving c1 and c2 firstly. We'll get c1 e power x plus c2x e power x. Now write the terms involving x cube e power x log x. We'll get plus x cube e power x log x by 2 minus x cube e power x log x by 3. Now write the terms involving x cube e power x cube e power x by 9 minus x cube e power x by 4. This gives us y equals to, now take e power x common from the first two terms. We'll get c1 plus c2x e power x. Take x cube e power x log x common from the next two terms. We'll get x cube e power x of log x, log x of 1 by 2 minus 1 by 3. We just took x e power x log x common from these two terms, right? Now take x e power x common from the last two terms. We'll get x cube e power x times 1 by 9 minus 1 by 4. This gives us c1 plus c2x e power x plus x cube e power x log x into 1 by 2 minus 1 by 3 is 3 minus 2 by 6, which is 1 by 6. Just replace it with 1 by 6. You'll get 1 by 6 x cube e power x log x plus x cube e power x into 1 by 9 minus 1 by 4 is 4 minus 9 by 36, which gives us minus 5 by 36. Now just replace 1 by 9 minus 1 by 5 with minus 5 by 36. Okay, this gives us y equal to c1 plus c2x into e power x plus 1 by 6 x cube e power x log x minus 5 by 36 x cube e power x. Okay. Or we can write this as c1 plus c2x into e power x plus x cube e power x log x by 6 minus 5x cube e power x by 36. Now just take LCM of 6 and 36. This gives us y equal to c1 plus c2x into e power x plus LCM of 6 and 36 is 36, right? The denominator of first term we are having 6, so we'll close 1 6 and multiply 6 to this numerator. We'll get 6 x cube e power x log x minus here we have 36, so we have nothing to multiply with this numerator, so just write minus x cube e power x is equals to c1 plus c2x into e power x plus, you can just split the fraction as 1 by 36 into 6x cube e power x log x minus 5x cube e power x. The next step we'll take x e power x common. We'll take x cube e power x common from these two terms. So this gives us c1 plus c2x into e power x plus 1 by 36 into x cube e power x of 6 log x minus 5. Therefore, y equal to c1 plus c2x into e power x plus 1 by 36 x cube e power x of 6 log x minus 5. This completes the problem. So we have seen a problem from variation of parameters method in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.